Hello everyone, welcome to TV Math Hub, your online home for clear, practical mathematics lessons. I am TV, and in every video, we focus on making mathematics simpler, one concept at a time. Let's get into today's lesson. Hello viewers, welcome to our today's lesson. Today, we shall be focusing on what we call the differentiation of logarithmic functions. So I expect by the end of this session, all of us to be in position to differentiate expressions that involve logarithmic terms. We shall be saying that the logarithm of a number to the base of e is what we call the natural logarithm. So if we have the natural logarithm of a number, say x, if we have the natural logarithm of a number, say x, we shall be denoting this by what we call log e of x. Remember, we are saying any logarithm that has got a base of e is what we call a natural logarithm. So if you are talking about natural logarithm of x, then we shall have log e of x. This will also be commonly represented by what we call ln. Ln represents log e. So it means ln of x will be representing log e of x. So in most cases, instead of writing log e of x, we shall be using ln of x, but the two are the same. So how best can we differentiate functions or expressions consisting of natural logarithm? Now, we shall first of all let our log e of x to be equal to y. If that is the case, then we can easily have e to power y, which is equal to x. We understand from what we call the laws of logarithm. If you have log of ab equaling to c, then it implies that this b will be equal to a to the power c. That is from the rules of logarithm, so we can be in position to write this. So if you have your log e of x equaling to y, then your x can be e to the power of y. So since we know that, we can easily write this. And for that case, if we differentiate on both sides, with respect to x, then we shall be able to get this expression. And from there, we can as well see that this expression here, this one here can be differentiated. But recall the fact that if you are differentiating a function, if you are differentiating, for example, y squared with respect to x, you differentiate this normally, that is 2y, but you must show that you have differentiated this expression with respect to x. So that is the same technique we shall use here. We shall be differentiating e to the power y with respect to x. So when you differentiate e to the power y, then you get e to the power y. But because we are differentiating this function of y with respect to x, we shall put there the y x, and that's why we have this statement here. So this is e to power y dy dx, which is same as dx of x. So if that is clear, we can now write that dy dx will be equal to, when I make the dy dx the subject, I will have this divided by e to power y, which will give us this given expression. So from there, we can easily write y dx, which is d dx of e to the power y divided by e to power y. So what is e to power y? E to power y is x. From this given point here, e to power y is equal to x. So where there is x, we can easily put e to the power of y. So y dx is same as d dx of e to power y divided by e to the power of y. So we can easily generally say from this given step here that dy dx, this dy dx is equal to, here you realize that you are differentiating e to power y, but again you are dividing by e to power y. So in general, we can say that when you are differentiating Lin function, that is a ln of any given function, meaning that our y which is here is ln of a function, for example x. So it means when you are differentiating a function that is containing ln of that function, then you will be saying that you differentiate that function there, then you divide by the same function. So here we are differentiating e to the power y, we are dividing by e to power y. So in general, we can conclude that when you are differentiating natural logarithm, when you are differentiating ln f of x, you will differentiate f of x, then you divide by f of x. That is same as having f derivative of x divided by f of x. We can look at examples to understand this concept better. So what we need to recall is that when you are differentiating a function consisting of ln, then differentiate that function, then divide by the same function. That is basically what we need to know about differentiation of natural logarithm. Viewers, let us now look at some few examples to understand this concept better. So the question says differentiate the following with respect to x. So what do we need to differentiate? We need to differentiate ln of x. So how do we do that? So we shall first of all let our y represent ln of x. So then next we shall differentiate this function with respect to x. So differentiate this function with respect to x. When you differentiate the function of y with respect to x, you will differentiate this normally, but don't forget to put dy dx because you are differentiating a function of y with respect to x. So when you differentiate y, you get 1, but because we are differentiating this with respect to x, so we must put dy dx. So this is equal to, now recall friends, recall that when you differentiate a Lin function, you differentiate the function, then divide by the same function. So what we shall do here, we shall differentiate our function, which function is now x, then we divide by the same function. So this will give us y dx, which is equal to differentiate x with respect to x, and you will get 1 divided by x. So this will imply that when you differentiate ln of x with respect to x, you will get 1 upon x. I hope this is clear to all of us. We can look at now the next question. I'm now convinced that part A is now clear to all of us, and we shall now go strictly to part B. So what is part B? Part B says we need to differentiate ln of 1 minus x. So we shall follow the same procedures as we did in part A. So what shall we do first? We shall first let our y to be ln of 1 minus x. The next step is to differentiate with respect to x on each of these numbers here. So that is d dx of y and d dx of ln of 1 minus x. So when we differentiate y with respect to x, we shall get dy dx. And this will be equal to, as we said, we shall differentiate the function, which is 1 minus x. This is our function. Then after differentiating this function, with respect to x, you divide by the same function. So what shall we have? This will give us differentiate 1, you will get 0 with respect to x, differentiate negative x, and you will get negative 1. This will be divided by 1 minus x, and this will be dy dx. And this implies that when you differentiate ln of 1 minus x, you will get negative 1 upon 1 minus x. Hello viewers, let us look at part C. So part C is saying that we differentiate ln sine of x. And I'm hopeful that at this moment, everyone knows how to differentiate sine of x. So if you know how to differentiate sine of x, then how best can we differentiate ln sine of x? Following the same procedure, we shall have our solution as we let our y be ln sine of x. And from there, we shall differentiate with respect to x, y, and we shall do the same for ln of sine x. What shall we have here? As usual, we shall be able to get dy dx. So dy dx is same as I said at the beginning, to differentiate ln of a function, you differentiate that function. So you will differentiate your function, which is sine of x. Then you will divide by what we call the same function, and that is sine of x. So differentiate sine of x, friends. I hope at the moment you know how to differentiate sine of x. When we differentiate sine of x, we get to what we call cos of x. So differentiate this one here, you will get sine cos of x, and we shall divide by that same function, which is sine of x. So our dy dx will be same as cos over sine. But we cannot leave this one here. As mathematicians, we can be in position to simplify this further. So cos of x divided by sine of x is what we call cot of x. So this means that y dx is same as cot of x. And that will be the answer when you differentiate ln sine of x. Hello viewers, I hope everyone now is in position to differentiate ln of any given function. So finally, let us talk about part D. So part D is saying we differentiate ln tan of x as we have done for sine of x, as we have done for ln of 1 minus x, as we have done for ln of x. We shall do the same for part D, and that is ln tan of x. So let us look at the solution. How do we differentiate ln tan of x? So our solution will be to let y to represent ln tan of x. If that is so, differentiate on both sides with respect to x. So from there, when you differentiate y with respect to x, you will get dy dx. And this will be equal to differentiate your function. The function we are having here is tan of x. Differentiate your function, divide by the same function. So what will this one give us? Differentiate tan of x. I hope everyone knows at this given point what you get when you differentiate tan of x. In case you don't know this, please check my previous videos. We talked about how to differentiate trigonometric ratios. So you'll be able to get that. So let us look at how best we can do that. So we are saying to differentiate tan of x, we will be able to get sec squared of x. And this is divided by tan of x. However, as mathematicians, we shall not leave our expression here because this expression can easily be simplified. So this is sec squared of x. But what is sec squared? Sec squared is 1 upon cos squared of x. So we are dividing by tan of x. Tan of x is same as sine of x divided by cos of x. So we can try to simplify this further, and it will be in position to give us 1 upon cos squared of x times the reciprocal cos of x divided by sine of x. So from there, 1 cos will cancel out, which shall remain with 1 upon cos of x times sine of x. But still, we cannot leave it here. We understand when we see this expression here, then we should be thinking about the expression for sine 2x. We know that sine 2x is same as 2 sine of x cos of x. So looking at this, you realize that cos of x sine of x is already there. So what are we missing? We are missing a 2. But this 2 can be easily created because we can easily create a 2. For example, if I create this 2 here and reorganize this to be 2 sine of x cos of x, if I don't want to change the meaning of this expression, I must also multiply a 2 in this numerator. So I've multiplied 2 both in the numerator and the denominator. So when you do that, it means the 2 will not change this expression here. Doing this will not change the meaning of this expression. So what shall we have? We shall have 2 upon 2 sine of x cos of x. But we can easily see that this expression that we have in the denominator is actual expression representing sine 2x. So this will give us 2 divided by, sine of 2x. But still, we cannot leave our answer at this given point. We can still do something from here. So we can still say this is 2 cosec of 2x, because we understand that 1 upon sine of x, 1 upon sine of x is same as cosec of 2x, is same as cosec of x, which means if we have 1 upon sine of 2x, it will be cosec of 2x. So that is basically what we are having. So this means that when we differentiate, this means that when you differentiate ln tan of x, you will get 2 cosec of 2x. In conclusion, we shall be saying that in general, whenever you are differentiating ln of any given function, you will differentiate the function, then you divide by the same function. This is the guiding principle. So whenever you know this, you can always differentiate ln of any given function. If you find this video helpful, don't forget to subscribe, like, and share to your friends. Thank you for being on TV Math Hub. We meet in our next lesson.
Yeah.